Okay, this is another video for my IB kids to learn proofs. And so this one, our book calls this proof by exhaustion, and you'll love and hate this name because it does get rather exhausting. But the idea is that you're going to exhaust all possibilities. So the proof by exhaustion is actually this part, but what I have seen in some of the IB prompts that they give is that they'll ask a show that, and then they're going to expect you to use this in the next part. So anytime they say hence means you must use the first part to do the second part, okay? Sometimes they'll say hence or otherwise, which is like, hey, look, you just did something that will help you with part 2, but if you have no idea what to do, otherwise you can do it other ways, okay? When they just say hence and you don't follow the same the thought process from before, you won't get the marks, okay? So hence means you've got to follow what came before. Okay, so on this first one, it says show that n to the fifth minus n is equal to n minus 1 times n plus 1 times n squared plus 1. Okay, so what I'm going to do is I'm going to say, okay, well, n to the fifth minus n is equal to, well, this is n squared minus 1. If I regroup these two right here, times n squared plus 1. So what I recognize is that I've got the difference of, this is a minus b times a plus b, which gives me a squared minus b squared. Okay, now I also see that this and this is also another a minus b times a plus b. Okay, so n to the fifth minus n is equal to, this squared becomes n to the fourth. We'd lose our middle term when we do, it's a minus b times a plus b. So that times n. Okay, and now I have n to the fifth minus n is equal to n to the fifth minus n. And thus we finished. I like a little check mark, or you could say QED because it makes us feel cool. Go Google the Latin. I don't know it. Okay, so then the next part, that was fun and interesting, but the next part says, hence prove that n to the fifth minus 5 is divisible by 5 for all n element of the integers. Okay, so with this one, this is a proof by exhaustion. And so we have to exhaust every possibility. So if I think about it, if I take, well, I have 1, 2, 3, 4, 5, 6, 7. Okay, and I keep going. What you notice is if I were to say, okay, what happens when I divide these numbers by 5? This is just scratch work to help you understand what's happening. Well, if I try and say 1 divided by 5, I would get, well, it's 0 with a remainder of 1. Okay, if you think about that, so 1 divided by 5, it's going to go in there 0 times. It's going to have a remainder of 1, and so we would have said 1/5, which seems kind of like a silly way to say that. It's just 1 divided by 5 is 1/5. But what is happening mathematically is that you've divided it, and you have a remainder now of 1. Well, if I divided by 2, I'd have a remainder of 2. 3, remainder of 3, divide 4 by 5, and I'd get a remainder of 4. And then once I get to 5, I have a remainder of 0. It divided in evenly. Well, now, as I keep going, 6 divided by 5, so 5 goes into 6. Well, it goes in 1 time with a remainder of 1. So that's 1 and 1/5, or you know that to be 6/5. Okay, I know this is really basic, but I just want to make sure we understand what's happening. So either you have a remainder of 1, 2, 3, 4, or a remainder of 0, and then beyond that, you just cycle back. It's always going to be kind of, here you'd have a remainder of 1, a remainder of 2. By the time you get to 10, you have a remainder of 0 again. Okay, so what we're going to say is, how do we want to begin this? If we divide n by 5, I'm trying to follow the book. We have a remainder of 0, 1, 2, 3, or 4. Okay, therefore, every value can be written as, okay, if it has a remainder of 0, it says 5k. So that would 5k plus 1, 5k plus 2, or 5k plus 4. Oh, sorry. Can you see all what I'm doing? Okay. So any number, any integer, if we're going to divide it by 5, we can rewrite that integer as either 5k, 5k plus 1. So these are all the cases that we might need to exhaust. Okay, once again, proof by exhaustion. So in this particular scenario, we know if our n, so now we're going to go through all of our different cases. And sometimes we might write like out to the side case 1, case 2, that sort of thing. So this first one, if n is equal to 5k, then this, right, oh, sorry. Then this right here, we could plug in 5k right to this. Then we have then 5k minus 1 times 5k times 5k plus 1 times, well, 5k squared plus 1. Right here, we know that this whole thing is going to be divisible by 5. Is equal to 5 times a new value p. It's divisible. The next one, if n is equal to 5k plus 1, then we have this first one, 5k plus 1 minus 1 times 5k plus 1 times 5k plus 1 plus 1 times, well, 5k plus 1 squared plus 1. And this, which implies 5k times all of that, which would be equal to 5 times some value p. Okay, which would be divisible. The next scenario, so we need to look at the next scenario. If n is equal to 5k plus 2, then what happens when we plug this in? Let's see, we get, well, 5k plus 2 minus 1 times 5k plus 2 times 5k plus 2 plus 1. Okay, here's going to be a 5k plus 1, not divisible, this is 5k plus 3. So what we're going to need to do is going to have to clean this up. Oh, 5k plus 2 squared plus 1, which implies, okay, I'm just going to look at this part. Partly, maybe we should write all of this out. I'll have to think about that. But for the sake of our video, you don't want to see me write all of that. It's just not worth our time. This becomes 25k squared plus, that is 10, double it is 20k plus 4 plus 1, which implies all of this stuff that I didn't write, times, and now notice I can factor out a 5, and I'm left with 5k squared plus 4k, and then this became 5 and plus 1. And so therefore, this would be equal to 5 times some value p. Or maybe, now I'm thinking about it, I'm not sure that I would do this. So then I could say this would imply it's divisible by 5, which, okay, so here this implies it's divisible by 5. Okay, maybe don't say that, but this implies that it's divisible by 5. Might be my preference on how to say that one. Okay, so we've done 1, 2, 3 cases. We've got 2 more to go. If n is equal to 5k plus 3, it's almost my lunchtime, then I have that 5k plus 3 minus 1 times 5k, where am I, plus 3 times 5k plus 3 plus 1. Okay, none of these are going to be divisible by 5, so the hope is that this last one better be 5k plus 3 squared plus 1, which would imply all of this that maybe I should write out, times, this is 25k squared plus 15, double that is 30k, plus 9 plus 1. Oh, good, 9 plus 1 is 10, that's divisible by 5. Which would imply all this mess that I didn't write out that I probably should. 5 times 5k squared plus 6k plus 2, which implies, therefore, that this is divisible by 5. The last one, let's see if I can fit it on or if I need to grab another piece of paper. If n is equal to 5k plus 4, then what we find here, okay, is that we'd have 5k plus 4, minus 1, times 5k plus 4, times 5k plus 4 plus 1, oh, there it is, times 5k plus 4 squared plus 1. Okay, so I should probably write out this part here, and then this is multiplied by 5k plus 5 times that. Okay, I'm using shorthand, I'm so sorry. And this shows that we've got a 5 times this k plus 1. So it's all the other stuff and all the other stuff, which would therefore imply that this is divisible by 5. And then we should summarize all of this and say, so since, maybe I shouldn't write on the back, but since n is divisible by 5 in all cases, or not, maybe not n, since, I'm sorry, n to the 5th minus 5 is divisible by 5 in all cases, comma, n to the 5th minus 5 is divisible by 5 for all n element of the, what were we looking at? Of the integers. Okay, these really take practice. So I've given you a couple of problems that I think you should practice, and I'd encourage you to work at it. So this proof by exhaustion is where you exhaust all the possibilities. Our book, let's see. Okay. Our book wrote it, well, here's what the book says. So if you want to look to see, I proved it a little bit differently than they did. And also, they started with a slightly different problem. And then here's the rest of their problem. Okay. I think I feel comfortable with the work I did. Good luck. Go practice.